Welcome to the video lecture series on theory of computation. In today's video lecture, we'll be learning about converting a Moore machine to mealy machine. And as far as Moore machine is concerned, the output is actually depend only on the current state. But when we go for mealy machine, output not only depends upon the current state, it also depends upon the current input. So that is the only difference between mealy and Moore. Okay. So here, Moore machine output depends on current state. Okay, and in mealy machine output depends on current state as well as and current input Now in this case we have to convert this Moore machine to mealy machine. So first step what we have to do here is we will just try to make a transition table for this Moore machine. From that we will convert that into a mealy machine. Okay, so the steps for converting that is, now we will draw a table. So we will have current state. So CS is called as a current state. Now here I will have next state, and next state we have two inputs here. So we have 0 and 1, isn't it? So 0 and we have 1, and the third one is called as output. So we have output. Now we have to make this table format. So first we will just convert that into a table format. So current state is here, next state and output. So next state we have to identify based on these two inputs called as 0 and 1. Now what are the states here? So we have altogether 5 states spanning from Q0, Q1, Q2, Q3 and Q4. So there are 5 states here. So in these 5 states, you first check it out what is the outputs. Okay, so what is the outputs for Q0? Q0 have an output called as 0. So we'll make it as 0. And Q1 has an output called as 0. So again Q1 is having 0. Q2 is having an output called as 0. Q3 you have an output called as 1. And Q4 slash 1. Okay, so after the slash whatever you find in the state is called as output. Okay, so Q4 has an output called as 1. Now what are the inputs here? Now we'll just make a bifurcation for this next state. When 0 is applied in Q0, where it goes? In Q0 when we apply 0, it goes to Q1. So I go to Q1. In Q0 when 1 is applied, it goes to Q2. So I go to Q2. In Q1 when 0 is applied, it is coming to Q1 itself. When 1 is applied, it is going to Q3. In Q2, when 0 is applied, it is going to Q4. When 1 is applied, it is coming to Q2 itself. In Q3, when 0 is applied, it goes to Q4. In Q3, when 1 is applied, it goes to Q2. In Q4, when 0 is applied, it is going to Q1. In Q4, when 1 is applied, it is going to Q3. So this is called as a transition table. For this transition table is meant for Moore machine. Okay, it is for Moore machine. Now we have to convert this into a mealy machine. So how to convert this into a mealy machine? Now see here. So first we will just take mealy machine. Not only depends output, not only depends on the current state, it also depends upon the current input. Here. Now what we can do is we can draw this mealy machine now. So start from Q0. Okay, Q0. Now when you closely introspect this, okay, Q0, when 0 is applied, when 0 is applied, where it goes to Q1, isn't it? When 0 is applied, it goes to Q1. Okay. So when 0 is applied, it is going to Q1. But understand that what is the output for Q1? What is the output for Q1? Output for Q1 is 0. So I write it as 0 bar 0. Okay. In Q0, when I apply 1, it goes to Q2, isn't it? In Q0, when I apply 1, it goes to Q2. Now, when I apply 1, it goes to Q2. But what is the output for Q2? Q2 slash 0. So the output is 0. So I put Q1 1 comma 0. Now coming to the next one. In Q1, when 0 is applied, it is coming to Q1 itself. So I make like this Q1. When 0 is applied, it is coming to Q1. But what is the output for Q1? It is 0. So I write it as 0 comma 0. In Q1, when 1 is applied, it goes to Q3. So now in Q1, when 1 is applied, it goes to Q3. And what is the output for Q3? Output for Q3 is 1. So I write it as 1 bar 1. Okay. So the first input is, the first part is actually input. The next part after this bar is called as output. Okay. In Q1 has been completed. Now go to Q2. In Q2, when 0 is applied, it is going to Q4. Okay. So I just write it as Q4. When 0 is applied, it is going to Q4. Now, what is the output for Q4? Q4 output is actually 1. So, write it as 1. In Q2, when 1 is applied, it is going to Q2 itself. Okay. So, in Q2, when 1 is applied, it is going to Q2. So, 1 bar. And what is the output for Q2? Output has, Q2 has an output called as 0. Okay. Now, we'll go for the next one. So, Q2, 0 and 1 has been completed. Q3, we'll go for Q3 now. Q3, when 0 is applied, it is going to Q2. So, Q2 is here. In Q3, when 0 is applied, it is going to Q2. And what is the output for Q2? Output for Q2 is 0. So, 0 bar 0. In Q3, when 1 is applied, okay, sorry. In Q3, when 1 is applied, it is going to Q2, isn't it? So, I make it as 1 bar 0. Okay, small change here. So, it should be 1 now, isn't it? When 1 is applied, it is going to Q2. In Q3, when 0 is applied, it is going to Q4. Okay, so when 0 is applied, it is going to Q4. And Q4 has an output called as 1, so I write it as 0 bar 1. So Q3 has been completed. Now go for Q4. In Q4, when 0 is applied, it is going to Q1. In Q4, when 0 is applied, it is going to Q1. So we'll just try to make this diagram. So I'll make a loop like this. Okay. In Q4, when 0 is applied, it is going to Q1. And 0 is applied. Even what is the output for Q1? It is actually 0. So 0 comma 0, 0 bar 0. In Q4, when 1 is applied, in Q4, when 1 is applied, it is going to Q3 itself. It is going to Q3. So I make a loop here, connection here. So Q4, and when 1 is applied, 1 bar. What is output for Q3? Output for Q3 is 1. So I write it as 1 bar 1. So that's about the diagram of mealy emission. Now we will try to convert this into an equivalent transition table. So I will put a transition table here. So I will use a different color in this case. Okay. So now we have outputs like this current state. To draw the table for mealy emission. So this is the format for mealy emission, a table format for mealy emission. So you have current states here, Q0, Q1, spanning from Q0 to Q4. Now next state and the current input is called as 0. In this case, next state and current input is called as 1. Now when 0 is applied in Q0, where it goes? In 0, when 0 is applied in Q0, it goes to Q1. And what is the output for Q1 here? Now Q1 output is actually called as Q1 output is called as 0. 0. Okay. Now when 0 is applied in Q1, where it goes? When 0 is applied in Q1, it goes to Q1 itself. Now what is the output for Q1? It is 0. So again, okay. Now in when 0 is applied in Q2, where it goes? In 0, when it is applied in Q2, it goes to Q4. Now what is the output connected to Q4? Output connected to Q4 is called as 1. And when 0 is applied in Q3, when 0 is applied in Q3, it goes to Q4. So output connected with Q4 is again 1. When 0 is applied in Q4, when 0 is applied in Q4, it goes to Q1. And output connected with Q1 is 0. Okay. Now when 1 is given for Q0, where it goes? When 1 is given for Q0, it goes to Q2. And output connected with Q2 is 0. Okay. When 1 is given for Q1, where it goes? When 1 is given for Q1, it goes to Q3. And output connected with Q3 is 1. Okay. Always see what is bar with Q3, isn't it? So that is the output. Now, when 1 is given for Q2, where it goes? When 1 is given for Q2, it goes to Q2 itself. So output connected for Q2 is 0. When 1 is given for Q3, when 1 is given for Q3, it goes to Q2 itself. Okay, now output connected with Q2 is 0. When 1 is given for Q4, when 1 is given for Q4, it goes to Q3. And output attached to Q3 is 1. Now this is called as a mealy emission table. Okay, so this is the way of converting Murray emission to mealy emission. So one point which we have to remember, that is a very significant point. Murray emission depends only on the current state. Output depends only on the current state. But mealy emission output depends on the current state as well as the current input. So that is the only difference, and this is called as a conversion mechanism of Murray emission to mealy emission. So thanks for watching the video. Have a good day.